welcome back to Easy Steps with Jenny. So today we'll be doing study unit 7, the non-parametric methods. So this is the part 1, which is the sign test. So this is basically one population. So we'll be following the understanding that we had all along of hypothesis testing, whereby we'll be required to state the null and alternative hypothesis. You'll be required to calculate the test statistic, and then what you'll also be required to do is to calculate the critical values. So here they won't give you the p-value, where you just compare it against significance level and then make a decision or draw conclusions. So it's going to be a little bit different, but I'll just show you guys how to do it. Now let's take this example that we have here. It says psychologists claim that the median time it takes South Africans to become aggressive in a life-threatening situation, which is the reaction time, is approximately 5 seconds. They do a study on 7 people in which they seemingly endanger their lives. For each subject, they measure uh, the time it takes the person to become aggressive and record the results, which are summarized in the table below, the following table. So this is for South Africans. So we have 2.5, 3.8, 4.1, 4.9, 5.2, 5.5, and 6.8. So these are the reaction time of 7 people. Now the question says use sign test to test the psychologist's claim. Formulate the null and alternative hypothesis, show all your calculations, and fully explain any conclusions, and use a significance level of 10%, alpha equal 10%. Now we have 5 steps here, and like I said, they won't give you the p-value, and which you have to compare against the significance level. Now this is different because on other test that we're dealing with the mean, which was this sign. So now we're going to be dealing with the median as our population parameter, and the median is denoted by this sign over here. So we'll be using this sign. It's more like an N, but protruding down a little bit. So now the same understanding that we know the null hypothesis, we know what's the null hypothesis by now. Then they said it's approximately 5 seconds. So you're going to say is equals to 5. I'm going to say is equals to 5. And for the alternative, because they didn't say less than or greater than, they just said approximately 5, then you're going to say your N is what? I'm going to say N is not equal to 5. Not equal to 5. Now, this tells us that we're dealing with two-sided hypothesis. So we know what is a two-sided hypothesis, we know what is a left-sided hypothesis, and what is a right-sided hypothesis. I explained this in study unit 3. Now, this is how you state your null and your alternative hypothesis. Just like this, simple. Step number 2, specify the significance level and the test statistic. So the significance level they gave it to us, it's equals to 10%. So you just write it like alpha is equals to 0.10. Now, if you're dealing with two-sided hypothesis, I'm just going to explain it now over here. If you're dealing with two-sided hypothesis, you have to divide your alpha by 2, because it's going to help you when you making when you state the decision rule, step number 4, and when you also make the decision and drawing conclusions in step number 5. So meaning from here, you have to say now your alpha over 2 is equal to, that is 0.10 over 2, and is equals to 0.05. So always, if you're dealing with two-sided, if your alternative hypothesis is like this, they didn't say less or greater, or they said different, then that's when you're going to use this, and then just divide your alpha by 2 right away. Now the test statistic, because it says also you must specify the test statistic. The test statistic that we use is called B. That is the B test statistic for the sign test. It's going to be different for the rank sum test, which is part 2. I'll explain that in the next video. Now B is equal to the number, of values more than x. So in this case, this x here is your population parameter number, this number over here. So meaning that you're going to compare the values that you have in your sample size with this value over here. So the numbers that are more than number of values more than x will be your value of b. Now step number 3, that is step number 2, you just have to specify the significance level like this and your test statistic. I don't think they'll ask you this question, but here, because it was just a one long question of 5 marks, then it should be done like that. Now, step number 3, calculate the test statistic. You see it says test statistic and critical values. So meaning that you're going to do some complex calculation, something you're not used to, but I'm going to show you how to do it. We're going to start with the test statistic. So since all this is called a sign test, we're going to put a sign for each and every number in our data values. Now, in this case, they put them in ascending order, so it's going to be easier to do it. So the first one is going to be a minus because it's less than 5. This one is going to be a minus as well. This one is going to be a minus. This one is also a minus. And then this one is going to be a plus. This one is going to be a plus. And then this one is going to be a plus. So now, if you have a value in the data set that is equals to this, let's say maybe after 4.9 there was 5.0 before 5.2, you put 0 for that value. So it means it's 5 minus 5. So it's not going to be a negative or a positive because it's equal to that 5. So you put a 0 for that and then you cancel it out. So if let's say it was 8 of them and then one of them was 5, you cancel that 5 out, then you'll be left with 1, 2, 3, 4, 5, 6, 7, like it is here. So I'm just making an example in case you see an example whereby you have one of the values equals to your main claim, or x in this case. Then from there, just counting how many values you have. 1, 2, 3. Those are the values that are more than. Then that is the value of b. That is your test statistic. Simple. Test statistic is equal to 3. Now the critical values. So the critical values is going to be a little bit tricky. I want you guys to pay attention. Now the critical values, this is how you're going to write your critical values. You're going to start with b and say b of n and alpha over 2 is equal to b of, what is the value of n? 1, 2, 3, 4, 5, 6, 7. B of 7 and alpha over 2. So now, where do you find this actual value? You're going to go to the table. It's there on Ifundi. It's there at the end of the textbook. The table looks like this. It's called critical values for the sign test. So you're going to go and look for where your sample size is 7 in this case. So if you have 12, you're going to look for 12 is 15. You're going to look for 15. So it's going to be 7 for this one. So this is 7. And then because our alpha was 0.05, we divided 0.10 by 2. It is 0.05. So now you look for where 7 and this actually meet. Let me just look for, yeah, 7. It's going to go like this. 0.05 going to go like this. So this number here, which is 7, is going to be your critical value. This number here, 7. So 7 is our critical value. That's what we're going to write here, 7. That is the first critical value. So all these critical values are actually shown in the slides. You guys should just go and see them. So this is the first critical value. The second critical value is going to be n minus b of n and alpha over 2. Alpha over 2. Now this one is going to be equal to n is equals to 7 minus b of n and alpha over 2. We already found it here. B of n and alpha over 2 is equals to 7. So it's going to be 7 minus 7 and is equal to 0. It's equal to 0. Now this is our critical values. These are our critical values. So let me just move this a little bit here. This is our critical values. So we got the test statistic and the critical value. Now after this, what you do is you're going to state the decision rule. So now there are 3 types of decision rules. They are there in the slides. So I'm just going to explain the one for this one. Then I'm gonna give you guys an easier way to see or to state your decision rules or to make those decisions at the end. Now here, for this one, because it's two-sided, if it's two-sided, there are two parts of the decision rule. We're going to reject the null hypothesis H0. We're going to reject the null hypothesis, if, and then I'm just gonna say or reject the null hypothesis, reject H0 if, okay, so I'm just gonna use this to write the conditions. You reject the null hypothesis if the value of b, if the value of b is less or equals to n minus b of n and alpha over 2, b of n, this is n. Or you reject it if b is greater or equals to b of n and alpha. Now, um, this is the decision rule. You have to write it like this. It's there in the slides, so you're just gonna look at whether your alternative hypothesis is left, right, or two-sided. Since it's two-sided, we have two conditions. Now, uh, let's interpret this. You have to reject if b. You're gonna reject if b is less or equals to, what is this value? This value is this one over here. If b is less than 0, or or if b is greater or equals to 7. The value of b is 3. Is 3 less than 0? No. 3 is not less than 0. Is 3 greater than 7? No, it's not greater than 7. So basically, what you do, or the easier way to do this, if you have two-sided, you just write the smaller critical value. In this case is 0. Just write 0 here, and then you write another critical value, which is 7 here. And then you ask yourself, is this value in between? If that value is in between, then you do not reject the null hypothesis. You do not reject the null hypothesis because it's in between these two numbers here. It's in between these two numbers. But then if this value was, say, let's say it was 9, the critical value, I mean the test statistic was actually 9, then in that case 9 would be greater than this. So meaning that one of the conditions of rejection would apply. So in this case it doesn't apply. So it means here what we're going to do, we are going to say we do not reject the null hypothesis. And then the conclusion you're going to make is, if you do not reject the null hypothesis, it means the null hypothesis is correct. It means the null hypothesis is correct. This one is the one that is incorrect. So it means that if the null hypothesis is correct, then there is enough evidence. There is enough evidence. You're just going to say, if you do not reject the null hypothesis, if you don't reject the null hypothesis, you're going to say there is enough evidence to say that uh, South Africans have a median reaction time of approximately 5 seconds. So that's how you're going to write your conclusion. Because now the null hypothesis says equal to 5 and you didn't reject it. So there is enough evidence to say that South Africans have a median reaction time of approximately 5 seconds. 5 seconds. So that is the sign test. Now, an easier way to make the conclusions, let me just move this over here and then do a table for you guys so that you can actually get it easier. Oh, sorry, let me just see if I can no, it's fine. Let me just do it like this. I'm going to no, let me use the black one. I'm going to draw this thing for you guys. So now here I'm going to say test uh, type, test type, and then here I'm going to say decision So this is different from what is in the slides. I'm just making it easier for you guys to actually understand it. Now, if you have a left-sided hypothesis, if you have a left-sided hypothesis, um, left-sided hypothesis is where your alternative hypothesis, you say n is less than n0. In this case, it will be n less than 5. So this is the main claim. In this case, it's 5. Ne? So if this is the case, then let me just write all three of them. Then I'll just write those ones after. So this is when n is greater than the main claim. The main claim. And this is where n is not equal to. So this is when it's two-sided, not equal to the main claim. Now here, for this one, you're going to reject the null hypothesis. You reject the null hypothesis, HO, if reject the null hypothesis uh if b is less than the small critical value. If is more than is less than the smaller critical value. Control C, Control V, Control V. Okay. And then if it's right-sided, you reject the null hypothesis if b is more than the bigger if b is more than the bigger critical value. If b is more than the bigger critical value. And then here you reject the null hypothesis if b is not in between. If it's not in between, if b is not in between the two critical values, like here, if, like I said, if b was like maybe 9, it was not going to be in between the two critical values, then in that case would say reject the null hypothesis. But because it's in between, like it's 3, we do not reject the null hypothesis. So this is the easier way to do it. So all the time you should have the two critical values. The first one is going to be this one, the second one is going to be this one. So now after getting your critical values, then you just look at this over here. Reject the test type is n is less than the main claim. In this case, it's going to be 5. This is going to be 5. This is going to be 5. This is going to be 5. So that is how you you make the decision. So the test type is based on the whether it's left-sided, right-sided, or two-sided. So this is your alternative hypothesis, and this would be your decisions or your decision rule. Actually, yeah, let me just say decision rule. This would be your decision rule. This would be your decision rule. But don't write it like this. Don't write it like this. You should write it like this. This is just a way of making it easier for you guys to understand, but it's actually like this. So yeah, that is how you do the sign test. So if this was less than, because I only did for two-sided, let's actually erase this and say, okay, this is less than. If this is less than, let me say, so if this was less than, then you have two critical values, right? So you're going to look for whether the value of b is less than the smaller critical value. So if b is smaller than the smaller critical value, which is this, if b3 is less than this, but you can see that b is not there, is not less than this. So if this was less than, everything will be the same. And then you also say do not reject the null hypothesis, because you can see that b is actually greater, not less than this. And then that means in your scenario you'll be testing if the the reaction time is less than 5, instead of saying it's not equals to or approximately. You'll be testing if it's less than 5. So you'll be saying uh, you do not reject the null hypothesis, then you'll say there is not enough evidence to say that it is less than 5 in that case. You'll say there is not enough evidence to say that it is less than 5, because you wouldn't have rejected your null hypothesis. So it means there is not enough evidence for this in that case. The same applies if it's right-sided. If it's right-sided, it's going to be like this. And then you'll be testing if the reaction time is greater than 5 seconds. It's more than 5 seconds. In that case, what you're going to do is you're going to do everything else, and then after this you're going to say you're going to look for where B is, you're going to reject the hypothesis if B is more than the bigger critical value. This is the bigger critical value, the one that says 7. Is B more than 7? No, it's not. Then that means you do not reject the null hypothesis. So now it means for this type of a test, whether it was less, greater, or not equals to, the approach was going to be the same for everything, and then you are just going to change the part of your conclusion. But then making the decisions of rejecting the hypothesis will stay the same for everything else. So that is how you do the sign test, guys, and I will see you in the next video.